All right. I hope y'all's week was better than my week. My week was not so fabulous. Much of it is a blur, but yeah.
So and I learned how to water ski.
Okay. Who else has lost their appendix? Am I the only one here? Oh wow. Okay.
I might lose the
Congratulations.
I know people lost their
appendix. Well, it's not an uncommon thing, but it's a very strange experience. And what I thought was the most incredible thing about it was like, no, not the morphine. I didn't like the morphine. It hurt my chest. It was
What does
weird.
your appendix do for your body?
Okay, so that's a good thing. So your appendix is where your small intestine and your large intestine join, and it kind of hangs off the bottom of your large intestine. And it's what we call a vestigial organ because we really don't understand if it has a purpose at all. And there's a school of thought. Yeah, there's a school of thought that it's left over from some evolutionary process and it's not needed. Like some animals do have more than one stomach, like cows have 2 stomachs, right? So that's one school of thought. And another school of thought is that it might like work in some glandular way, sort of like hormones or neurotransmitters or it might secrete something, but we're really not sure. But yeah.
You're still alive, so it must not be that useful.
Well, here's the thing, and this is what I thought was so amazing. We're on the way home and Jason says to me, 150 years ago, this would have been a death sentence, and he's absolutely true. 150 years ago, not even that long ago, right about now, at about the 1 week point, I'd either be dead or darn close to dead. Because what they do, your appendix, it just hangs there. It's like this little tiny, it's like tinier than your pinky. It's like this, right? It's this little itty bitty pouch. And if it gets blocked by anything, and there's all kinds of stuff that's moving through your intestines, right? So if it gets blocked by anything, it starts to swell and it fills with bacteria, and sooner or later it breaks. And when it breaks, it spills all that infection into your abdominal cavity, and that can kill you. You can get septic and you can die. So crazy that I went to the ER and I came home within 14 hours. Something that 150 years ago would kill me. 14 hours and I'm totally fine. Yeah.
How did you know you need to have a...
So last week, during this time last week, I had a tummy ache, but I didn't say anything because it's a tummy ache, whatever. People get tummy aches, you just move on. And it stayed all day. It started in the middle. By the afternoon, it had wrapped all the way around, and my kidneys kind of ached, like everything around here hurt, and that was weird. And then when I tried to go to bed, it had shifted all down here to my right, and that's where your appendix is. It's down here on your right. So it had shifted all down here to my right, and I was like, that's really not a good thing. But it hurt a lot, and I couldn't sleep. So I came downstairs, and I sat up, because earlier when I was sitting up, it wasn't so bad, and I thought it was positioning. I didn't realize that it was passage of time that had made all the difference, right? Like literally it was a few hours earlier. It wasn't as bad. That's the thing. And I couldn't get comfortable. And that was about 1:30. And then about 3 a.m., Jason got up to go to the bathroom and saw that I wasn't there. So he yelled down, are you down there? And I said, yeah. And he said, are you okay? And I said, I don't think so. So we went to the ER and, they asked me what was going on. They stuck an IV in me and they drew a bunch of blood. So they checked things like your white count to see if you have an infection. And then the doctor, he smushed all over me over here. And then he smushed all over me over here. And he said he thought it was my gallbladder because I was saying it hurt higher than lower. And for some reason, every doctor I've talked to since then says they always think it's your gallbladder and it's always an appendix. But then they gave me a CAT scan and that's how they could see it. They could see that it was bigger. So then like 2 hours after the CAT scan, they took me back and this big, tall, soft-spoken Jamaican guy was my surgeon and he was amazing. He was amazing. I love him. It's like my new favorite person. Yeah.
Was he your slave or your surgeon?
Surgeon. No. I said surgeon. No, surgeon. Definitely not okay. Definitely not okay. No. Yeah, really. Henry. Think about what you say before you say it, okay? Surgeon. Not servant, surgeon. He was amazing. He's like my new favorite doctor. He's incredible. So, Henry. Gotta bring it down. It gets Henry. It's offensive, right? Like some people get very offended and with good reason. So let that go and move on from it, okay? All right. So let's look at our stuff, our lesson. Yeah, it was an interesting week for me. Needless to say, I was kind of fuzzy.
Too. That was
I heard. That's always great fun in your van. Yeah, okay. All right, so we're going to look at our notes, and we're going to whip through this. Now, those of you who did not do earth science last year, like I warned you, this is going to look like a ton of work at one time, and it is.
It is.
But we're breezing through it because any good earth science class, a good physical science class has an earth science component. And we're just trying to cover the component. Most everybody in here did it in depth last year. So we're covering it and moving past it. All right, so what we're covering this week was Earth's interior and surface, and Earth's surface in general, and water and weathering and all that kind of stuff, right? This is, to most of you, this is not new. Now, I want you to notice that on your notes under lesson 2, your second page, like the back of the syllabus page, there is a whole bunch of vocabulary. Did y'all see all that?
Yes.
Okay, so I've been asked what's that for. Basically, if you know what those words mean, you probably are going to do all right for the lesson. Because that's just like one other thing you can use to help study, okay? Sure.
On like page 6 of the lesson, there's like a bunch of weird formatting.
Yeah.
Yeah.
Like subduction of ocean plate.
There's definitely weird formatting. That's like I said, yeah.
Even 2 period, and 4 without a period,
Whoop.
1 with period, and 5 without a period.
Okay, Ken, we'll get to it. I did 9 lessons in about 4 weeks this summer, and it was insane because I had to do 9 lessons for you and 9 lessons for them, so that's 18, and they don't have these first 4 lessons in their book, so I had to write them and make video lessons and PowerPoint slides and all this business. It was nuts. So there's definitely going to be some formatting problems here and there, and that's why I said we won't even count those towards brownie points, because what now? You don't need PowerPoint slides. They don't have a lesson. They don't have any of this in your book.
PowerPoint is boring.
So I had to create all this for them.
Yeah, good.
All right, also, next week's lab. I want to show you, I want to talk to you about next week's lab for just a second. Next week's lab is really cool. Did anybody look ahead to see what it was?
No.
Okay, so next week's lab, what we're going to do is, what is that? Go away. Sorry, some little thing like lit up. It's recovering oil, and we're going to basically use pump bottles and hoses and oil and water and gravel, and we're going to try to see if we can get more oil out with cold water or hot water. It should be a really fun kind of like build something and work with it lab. Yes.
Did you say oil?
Oil.
Don't
like
you dare.
Yes, she did.
No, I said I don't know what you want to bring, but
Exactly. I don't know what it is either. We're going to leave it there. All right.
Bro.
Do you need a chill break for a minute, or can you get it yourself under control? All right, we're good. I don't know. Let's just move on. All right, so let's look at lesson 2. All right, let's look at our notes. So, did you notice, for those of you that were looking through the book and filling in the slots in your notes, did you notice that it pretty much follows exactly the pattern? Okay, everybody saw that, right? So it's going to be that way when we get to the physical science stuff as well, but hopefully we'll be more in depth and more detailed. This is just like hit the high stuff and move on, right? Okay, so we have Earth structure, and then it started with the science of geology, right? So what's our first blank say?
Geology.
Right, geology is the study of planet Earth, including its composition. All right, so obviously then geologists or scientists who study Earth and its processes. All right, somebody explain number 3 to me. Who can do it? Go ahead, Michael. Uniformitarianism. Yeah.
The geological process that operates today also operated in the past.
Right, okay. Do you remember that when we talked about, last year we talked about superposition? That was part of the uniformitarianism. Okay, so superposition is the idea that the oldest layers are on the bottom and the newest layers are on the top. So that do your hands function normally? So that, I don't even know. But it's that older stuff is on the bottom and the newer layers form on top, right? That's the idea of superposition. The idea that superposition exists today, as it did millions of years ago, is uniformitarianism. It means that the processes are the same. Okay, we're not going to assume that Earth operated under a different set of laws a long time ago. A good way to think about uniformitarianism, for those of you who haven't had it brought up before, is so who likes anything that's sci-fi or fantasy or who geeks at anything? Everybody here does, right? Come on, you're a Marvel person. There are rules, right? When you get to a universe, there are rules, okay? And some some people who create these alternate universes are really good at maintaining the rules, and some of them are not so good at maintaining the rules, right? And they bend the rules. So anyway, when you get the rules should be the same for every situation. Like I remember years ago, Buffy the Vampire Slayer. Okay, I was a huge Buffy fan. Yes, thank you, girl. I was a huge Buffy fan, and I still like Buffy. But there was a point when all of a sudden Buffy made no sense because suddenly it was like all the rules that the universe operated under weren't there anymore.
They weren't.
And there was a reason for it, but
1000%. Josh Whedon always has a reason.
the key,
Obviously.
it was the key. Anyway, okay, so cross-section of Earth. All right, what are the 3 main layers of the Earth? Who's got that for me? Ethan.
Crust, mantle, and core.
Okay, so those are your 3 blanks. Your crust is the rocky outer layer. And what is the material that makes up most of the crust? Silicates, right. All right.
Quartz,
Uh-huh.
etc.
Mm-hmm.
That's all I know.
Yeah, pure silicates like quartz, right? Like glass. You can see right through it. Mm-hmm. All right, how about the mantle? Somebody tell me about the mantle. Somebody. All right, go for it, Michael.
It has 3 layers. It's
It's the
lithosphere, asthenosphere, and mesosphere.
Uh-huh.
Um,
They all first.
the first
Right.
one's cold and rigid. The second one's softer, weaker rock, and it has a high viscosity but can flow just
Yep.
barely. It's a little bit more viscous than glass, but not much.
Okay.
And mesosphere is beneath the asthenosphere and is stronger and stiffer. And
Excellent.
right beneath the mesosphere is the core.
There's the core.
It's just,
All right.
It's just a hot piece of metal.
Yeah, and the core had a liquid and a solid part too as well, right? All right, so that's basically your 3 layers of the Earth. You could spend, we spent a whole week on just that last year pretty much, right? And you could do that. You could spend an entire lifetime on this, but we aren't gonna.
Let's not do that.
Yeah.
I would say no.
So let's look under section 2. It says 22 minerals. All right, somebody tell me about what is a mineral. All right, Lily.
A mineral is a naturally occurring inorganic solid with a crystal structure and characteristic chemical composition.
Perfect. All right. And there were many different kinds of minerals we learned,
Yes.
right? Lots and lots of different kinds. And some of them crystallize at cooler temperatures, some of them crystallize at higher temperatures, and that gets into, we get into the classifying rocks. That stuff gets really important.
It's fascinating.
Lily loves rocks, for those of you who don't know this.
Rocks are stupid.
I
They're
used
just-
to-
Lily was the only person in earth science who cared about the 3 or 4 chapters dedicated just to rocks.
It was
Like-
weird.
Healing gems.
No.
Not
No.
stop it. They
No.
are real.
Healing gems.
Kai,
They are real.
Kai, the only way that you
I calm down when I hold a rose quartz in my hand up against my heart. I don't know what you're talking
placebo
about.
effect. Stab.
You know
Ooh.
what? You're
He
a
went to the word.
rat.
It's the
So,
only way-
moving on.
Don't fight a gem.
So what's a rock?
This
rose
one-
quartz.
A rock.
A rock, Henry, what's a rock?
Stone.
A rock is a stone.
So you're-
A rock is a
Yeah.
solid combination of minerals and mineral components. All right, so,
Rocks and stones are different.
yes. All right, so we check our properties of minerals. Okay. Properties of minerals, all right? Now, when we had all the different minerals, remember we used these different properties to classify them, right? We used their crystal structure, we used their color, streak. How did we check streak? Who remembers?
Oh, you take a rock and you scrape it across a
Streak plate.
Ceramic.
Streak plate, yep, and then see what color it leaves behind, right? Okay, and then luster, that was the way it reflects light, right? And then hardness. Does anybody remember the scale on which you measure hardness?
The Mohs.
Good, the Mohs scale, very good.
Yeah,
All right. And then fracture and cleavage. And fracture is how it breaks, and cleavage is a fracture that is regular and flat and well-defined due to chemical bonds that are weaker or stronger, you remember?
The next thing
There's
is cleavage
some-
in the back.
The weaker ones break nice and flat.
Sure.
So, what now? Oh, factor. Okay, you caught one more. Excellent. All right, good. There's another one.
How many
All right, so I think you added 4 this week to whatever you had. So I think you had 6 before. Yeah, so you guys are, it's going to be real easy for you to get brownie points this semester because I was
64.
rambling.
No.
Oh, it is 64.
You're at 10.
We were at 6. and
Alright.
Yeah, it's 4.
It's
You're at
25.
10. 25. Yep.
I'm so busy.
All right, so if you think about, like, if you've ever seen the Native American arrowheads where they chip at them and those nice flat pieces come off and it makes those sharp angles,
Yeah.
that's cleavage that you're talking about there, right? So that'll be Miss Jackie, I
Stop
believe.
looking at me, Billy.
All right. Then moving on. Other properties. Are they magnetic? Are they fluorescent? Do they conduct electricity? All that. So classifying rocks. Lily, since you love rocks so much, would you mind reading like A, B? Actually, can you read that whole section? Do you mind reading it?
I do not.
Okay, listen for Lily. Fill in a blank if it's not filled in. Go for it, Lily.
Rocks are classified into 3 major groups: igneous, sedimentary, and metamorphic, based on how they form.
Mhm.
The igneous rocks are my favorite. Igneous rocks, they form from magma, and magma is a mixture of molten rock and gas which forms underground. Lava is magma that flows out onto Earth's surface. The intrusive rocks form underground, and the extrusive form above ground.
Excellent.
The igneous rocks form when molten material cools and solidifies either inside Earth or at its surface.
Perfect. Keep going.
And then sedimentary rock is formed from sediment, which is small solid pieces of material that come from rocks or living things.
Excellent.
Sedimentary rock is a rock that forms over time as sediment is squeezed and cemented together.
All right.
Geologists classify sedimentary rocks into 3 main groups according to how they form: clastic, chemical, and organic.
Okay.
Plastic form from fragments of broken rocks. The chemical form when minerals precipitate from a solution. And then the organic form from organic processes such as the breakdown of living things.
Okay. Anybody who was not here last year who is still writing notes? Are you still writing notes or do you have it all? Do you have it all?
I have.
You all have it all. Good, because this is what you need to study with. Excellent. All right. So go ahead and do metamorphic then, Lily.
So metamorphic rocks have been changed by temperature and pressure. And they are foliated metamorphic rocks have been formed in layers.
Mm-hmm.
Metamorphic rock forms when a rock is transformed by heat, pressure, or chemical reaction. Most metamorphic rocks form under high temperature and pressure deep underground.
Excellent. Okay, and then we have our rock cycle. Okay, now y'all probably saw this because it was on your homework sheet, right? Your questions. So let's look at it real quick. Let's draw it. Yay. All right. So I know, but let's draw it again. Y'all gotta tell me what goes where. All right.
What's this, the rock
And
cycle?
again, tell me how to draw it.
Sedimentary, igneous, and
Okay, hold on.
Michael, be quiet.
Gosh, Michael.
Yeah, Michael.
Oh, that was aggressive.
Michael.
Okay. So this is the surface, right?
Can you open this one?
Oh, gosh, I didn't open it all. Can you see now? Okay, so here's our surface. So let's say we have, what do we have down here underneath anyway?
Magma.
Magma, okay? All right, we got magma. You all okay?
yeah.
Those noises
No,
are
the
freaking
boys
me
are
out.
dying.
Stop. We're high schoolers. All right. All right, what happens to magma as it reaches the surface?
It cools.
It cools, okay?
Oh,
All right, and then what forms up here?
Oh, sedimentary. Not sedimentary.
Igneous. Igneous.
Igneous rocks.
Uh-huh,
Now, we
but
got
it's like
igneous
a
rocks
first.
right kind of here, right? All right,
Shut up.
so up here we have what kind? Extrusive.
This tiny.
And what do we have down here?
Intrusive.
Intrusive. Okay.
Intrusive.
All right. What happens to these over time?
They cool.
They rise to the top.
Yep, they rise to the top, right? So what do we call that?
I'm really
Uplift.
smart, but I don't know.
Uplift. Very good.
It took me even like 30 minutes to try and find
No, it
out.
honestly did. We had to look it up. We found the original template. And we were like, oh, that's what that one is.
That's great.
Oh,
Okay.
yeah, the uplift. I had to look up the actual spelling.
And then what happens to them? What happens to them after they reach the
It
surface?
becomes
What's the process?
crumble. They erode. They erode.
Weather. Weathering.
Yeah.
Okay, they go through weathering. Okay, they go through weathering. All right, and then they become what kind of rocks? Sedimentary rocks. Okay, so they're up here.
You've been waiting for that moment.
And I got it wrong.
Danny,
They become sediment, and then they become sedimentary.
is it sedimentary rocks or sedimentary rocks?
Say that the way you want. I don't care.
Potato, potato.
Is it
Sedimentary.
what's the one I love so much that British people do?
No.
Oh, there's a couple of them that are really good. Oh, advertisement.
Honda.
My grandfather was Canadian. He'd ask you, did you see that new advertisement for the you know,
Oh, that would
whatever.
make me angry.
Advertisements.
My mom,
Advertisement.
my grandma
Henry,
said
4 feet on the
program.
ground, it ruins my floor. Thank you. Okay. So it becomes sediment, and then it moves into sedimentary rock, right?
Yes.
Sedimentary rock. Okay, and then what happens to the sedimentary rock? It goes down in here,
Heat and pressure.
right? Okay, so we get heat
Oh,
and pressure, and that can happen above or below, but most of it's probably happening below, right? If you were in a mountain that was above, and they'd be, you know, below the main surface, but still, I mean, above the main surface, but below the mountain. So they can still get heat and pressure there. Okay, you get heat and pressure, and then what do they become?
Magma.
No.
Metamorphic.
Got it.
I said-
Wait.
sorry, promise.
Metamorphic rock.
Man,
And then what happens to the metamorphic rock?
It becomes magma, and then the whole thing starts over again.
How does it become magma?
Oh, I don't know.
That's the easy
Why are
part,
you
guys.
smashing everything?
So aggressive.
I know. Stop banging on the table, y'all. Okay?
She said.
I'm making on my book,
Oh
actually.
my
Goodness
god.
sakes, y'all. Okay, so there's that. Moving on. All right, so that's our rock cycle, and that was part of the questions page. So y'all probably, you've seen it before. I mean, that's where they start showing it to you when you're like tiny, right? It's in all the little kid science books because it's fascinating. All right, so plate tectonics. Who would like to talk about plate tectonics?
I will.
Cole, go for it.
Volunteers tribute.
Okay, volunteers tribute. Yep, go for it.
Just read the whole thing.
Yeah, go ahead and read for us.
Okay, I think I got them all right.
Well, let's hope you did.
Plate tectonics is the theory, or let's do it. Plate tectonics is the theory that pieces or plate of the lithosphere move about slowly on the asthenosphere. The theory of plate tectonics explains the formation of the movement of Earth's plates. Continental drift. In 1912, Alfred Wegener hypothesized that continents were once joined into a supercontinent, which then broke apart into pieces that moved apart. I read that wrong.
Right.
Pangea, or all land, ancient supercontinents. Continental drift, the process of continents moving slowly across the Earth of the
Stop, Henry. Henry, you're
across
like
the surface of the Earth.
way too up here today. You got to bring it down.
Seaboard
Right.
spreading. Mid-ocean range, is that right?
Ridge, mid-ocean ridge. Yeah.
You gotta chill with that. World's largest underwater mountain range.
Okay.
Formation of the ocean crust, formed by seafloor spreading as new crust is created at mid-ocean ridges and older crust moves away.
Okay. Stop there for a minute. All right. So, thank you, Cole. Such a good
I messed
job,
that up
Cole.
3 times.
It's all right, Cole. It's okay. All right. So,
Good job, speech student.
we have, I know, right? All right. So, I'll see if I can find a quick video, but
Okay.
we looked at these last year where you can see, y'all, come on, where you can see Earth kind of change throughout time, and it's really cool. So the idea for those of you that aren't super familiar with it is that you've got plates, and that the crust is divided into plates everywhere, and that they're constantly moving. Okay, what is moving them?
Convection.
Convection current.
Convection currents, right? Okay, so somebody describe how do convection currents work?
We did a whole lab on this last year. In my lab.
We did. No, but can you describe how it works? Like, can you describe it?
I could. It's a current that pushes. It's the heat that it gets hot from the center of the core. It rises up because heat rises, and then it fell back down because it's cool because it's too far away from the core. And it keeps on going, so that moves in a circle, which moves the plates.
Right.
Because it's moving.
It's a constant movement. So,
Oh.
Plate tectonics
That
is my
was-
favorite.
soup and crackers, right? We did soup and crackers. So the idea is that you've got all this hot magma, and it's, if you've ever seen a lava lamp, the pieces go up and down in it. It's the same idea. That's convection heat. What we did is we took a big pot of soup and we put crackers on it, and we watched them move.
And then we got to eat them.
What is it
that was
about?
delicious.
Yeah. What is it
You
about?
described the whole thing.
What is it about the convection currents in Earth that makes them move the direction in which they move? Do we remember?
The heat.
It's in the
Yeah.
Yeah, it
The
has to
pole.
do with the poles and the magnetic poles.
I
All right, so you have Earth, all right, and you've got pole and pole, and they're magnetic, right?
It's because
Alright.
it's made of melted
Right.
iron, right?
Yes. And this is how we know that this actually happens, okay? This is how we know that throughout time, these have switched, okay? Like, you know when you have a magnet, you have a positive and a negative end, right? One that attracts and one that repels. We know that over time, these have switched. And not since we've been recording history, but the way we know is that at mid-ocean ridge like this, okay, we can look at the patterns of the seafloor spreading. So the seafloor is spreading this way. If let's just say we have North America over here and South America over here, so we know where we are. Europe and Africa. I'm not even gonna try to draw this. Okay, so we've got this, and it's going this direction, right? It's spreading this way.
AP.
And the reason we know
That's
that's enough.
Africa.
The reason we know that it's doing that, the reason we know that these have spread is when they look at the rocks on the ocean floor, they can see which way the iron fragments in the rocks are facing. Do you remember they align? So over time, you can look and see that maybe this first layer, they're kind of aligned like this, and in the next layer, they were aligned like that. Do you remember? And that's how we can tell over time that it has spread and the poles have switched. So while these move apart, it causes these plates to shift around, and over time, everything kind of bumps into stuff, and just like, you know, when we get into Newton, you got equal and opposite reactions, right? If one smacks into another, what's it gonna do?
It's gonna be bad.
Bounce back off and keep going the other way,
Do
right?
you believe in continental drift happen?
I do.
Some people don't.
Yeah, no, I do.
I think it too.
Let me get, if I can take this
Some
off.
people don't believe the continental.
Yeah, what's gonna be the thing?
That
Okay,
50 years ago.
so
But now that we have like.
Yeah.
let me show you this one.
With evidence, not proof.
Okay, let's watch this one real quick. I can make it bigger. There we go. I'm not gonna drop it. What is this about? Go away. Sorry, I'm gonna stand up so you can see better.
200 million
Yeah, just
years ago,
watch.
our world looked very different.
Yeah.
Iberia
I'm
rubbed
trying.
shoulders with Antarctica. Buenos Aires lay not far from Cape Town, and Morocco sidled up to New York City. The Atlantic Ocean started to open up around that time, beginning in the north. Tectonic plates moved apart and new crust formed in between. We can speed up time so that millions of years flash by every second. This change in tempo will allow us to witness geological time from our impatient human perspective.
We're very impatient.
Europe, North America, and Africa split apart first.
See, this is unrecognizable
As
to
the
us.
southern Atlantic
Right?
opens up, Africa and South America drift apart. The underwater ridge that traces the center of the Atlantic Ocean reveals the location of new crust forming. The youngest sections of the ocean floor lie nearest the ridge, with older, cooler, denser crust near the shoreline. The process seems smooth and stately from this perspective, but most of the plate's motion takes place in a series of adjustments we call earthquakes. Sometimes minute, sometimes monumental, these events shaped the landscape we recognize today.
Ta-da!
Like 25 million years.
Yeah.
It's still looking up normal. 25 million years. Is still kind of
Takes a long, long time to get, yeah.
Right, right.
Yeah.
Oh, I can't see that.
So, all right, so back to our notes. So that is our idea of plate tectonics. And the reason I think that's important to understand specifically when it comes to physics is because that's all physics, right? I mean, there's a lot of physics involved in what happens when they hit each other. So if we look under section 4, plate tectonics, oh, it's playing something else. What are you playing? That's awesome. Thank you. Okay. I thought I had paused it, but I had not. So when we start talking about subduction of ocean plates, as the seafloor spreads, heavier, more dense oceanic crust sinks below a neighboring plate. So you have a trench formed in a subduction zone. So subduction is this idea, right? All right, if this is the ocean plate and it's the heavier one, okay, and this is a continental plate, where's the ocean plate going to go when they hit each other?
Down.
Down, right? And that's subduction. It's going to go right underneath. And what's going to happen to this crust as it goes underneath?
It's gonna.
It's going to melt, turn into magma, right? And then it's going to move around inside. All right, so that's the idea of subduction. And it talks about mid-ocean ridges, which we saw, and there's a lot of earthquakes along mid-ocean ridges. What else is there also along mid-ocean ridges? Not just earthquakes, but what?
Just
It's not just earthquakes.
Tsunami.
Well, earthquakes causes volcanoes. Why? No, they're volcanoes. Why?
Because they blow out magma.
Because it's coming up from, Do you remember the part of the Pacific? What's the part of the Pacific called that has
The
all this
fire.
ring of fire? Yeah, that's where like,
Whoa.
wow. Okay. Krakatoa, that's where a lot of tsunamis come from. There's earthquakes. There's a lot of tectonic activity there. All right. So, theory of plate tectonics. Now, yes, there's some weird formatting here, and I apologize for that.
Yeah.
Plate motions are visible, part of the process of mantle convection. Plate boundaries. All right, there are three types of plate boundaries. There are divergent, convergent, and transform. Who can tell me what divergent means?
Divergent boundaries are places they move away from each other.
Away from each other. All right, how about,
convergent
con-
move towards each
okay.
other?
all right,
Transform, slide past.
right. So divergent plates move away. So that would be like the European, North American are currently moving away. Convergent, they move together. And then transform, they do this. Where do we have a transform boundary in the U.S.?
It's the Appalachian Mountains.
San Andreas.
San Andreas Fault. Yep. California. That's transform boundary. It's sliding over time. Remember we saw pictures of roads where like they painted a line and then you can look over the years it's shifted? Yeah.
So does that mean that to a degree, a divergent boundary and a transform boundary could be the same until they go past each other?
Divergent and
Because, like, a
transform?
convergent are coming towards each other,
Yeah.
but then they become transformed because they start passing each other.
Yeah, I suppose they could at some point. It would depend when they get there. Does one subduct or does it slide, right?
It's like
All right, so then we have the idea of mountain buildings, and geologists have found that most mountains form along what kind of boundaries?
Transform.
Yeah, plate boundaries in general,
Yeah,
transform
convert.
any of them, right? All right, so earthquakes, that's the movement in the lithosphere that occurs when rocks shift and it releases stored energy. So all that energy is already there. It's like if you we did this last year, remember you put your hands together and actually do them this way and press really hard. And then once you're pressing really hard, try to slide them. You feel the stick. Every time it sticks and the friction stops it, you got stored energy. So when you get, that's what the earthquake is, right? It's the release of that stored energy. Yup. So seismic waves are the vibrations that carry the earthquake's energy. And if you remember, there were different types of seismic waves. Who remembers anything about them, about seismic waves? We had different kinds. Remember?
There's SP and surface.
Right. The surface ones were the ones on the top. And what were the S&P? Do you remember how they went?
The SMP are longitudinal is P and then transverse is S.
Right. So one goes this way,
Yeah.
and then one goes
right.
this way. So when they smack into each other, that's when you get all of the, remember we did it with the slinky? Yeah. That was crazy, but it was fun.
That was pretty cool.
Yeah, it was a lot of fun. All right, so then stress in Earth's crust. As tectonic plates move, they cause stress in the crust, which in turn produces faults and folds. So what's a fault? Somebody who hasn't said anything yet. Somebody tell me what a fault is.
I don't know.
Go, Dylan.
A break in the rock.
Excellent. How about a fold? Somebody tell me what a fold is. Yeah.
A bend.
A bend in the rock. Okay, so earthquakes and seismic waves. Earthquakes occur because stress forces have exceeded the strength of the rock, right? The rock's going to hold up to a point. Once it reaches a point where it's too strong, it's not going to hold anymore, right? It's going to slide or break, whichever happens. So as rocks break and move, potential energy is converted into seismic waves. So here are three types of waves that Michael just talked about. You got P waves, they're longitudinal. They compress and expand like an accordion, like this, right? And then we had S waves, which move at right angles, like snakes. And then we had the surface waves, which do this rolling motion, like a pebble in a pond, right? All right, earthquakes, then we measure them. Let's see, to measure earthquakes and pinpoint their epicenters, geologists use seismic waves. using seismographs, and the seismograph is the device that records them. Remember, it was like a little needle thing, shaky, shaky, shaky.
Yeah.
All right, and then we had different scales. All right, which one do we use most often now?
Modified, well, we use it. Normal people use it all the time. But,
Yeah.
Mercury
But-
scale.
Mercalli.
Dude, you're
Mercalli.
saying normal people
Usually they're
There's a
using.
scientist.
Average.
as opposed to
Most people are most familiar with the term Richter scale, but we most frequently use modified Mercalli now. So the Richter scale measures frequency and amplitude. Moment magnitude measures the amount of energy released, and then the modified Mercalli has to do with damage, right? And that's very often what we see on TV when they give this earthquake was a 6.4. They just usually don't tell you what scale they're using. So most earthquakes are concentrated along plate boundaries where many faults are found. All right, volcanoes. Here's the fun stuff. I like volcanoes. They're actually cool. We're going to wrap up chapter 22 here. All right, so volcanoes. So somebody tell me the concept of how a volcano forms. What makes it happen? How's it happen? Who can do it? You can do it, Kai. You can do it.
Yeah, though.
Yeah, you can. You can.
I mean, like, you know, it starts like mountains under like the water and they form along like.
That's right.
Yeah, the magma.
Think about Hawaii. Okay, tell me
Yeah.
how does Hawaii form?
Well, it formed like they got built up over time underwater, and then when it finally like
Right.
exploded, right?
Yeah,
It
it's
like rose up.
there's a hot spot in the
there was a
crust.
hot spot, and then the hot spot like came up.
Right.
And it became a volcano, and then
So you have thinner crust, and you get some magma that erupts and comes up, and it leaves a little tube in the middle. Does anybody remember what the tube is called? The vertical chamber?
is it a pipe?
That's the pipe. Okay, and then underneath you've got the magma chamber, right?
Yeah.
So the magma chamber, the magma comes up the pipe, and what do you call the opening?
The vent.
The vent. Right. All right. And then if it is a volcano, over time it just continues to form, right?
Yeah,
It comes out and keeps growing bigger and bigger. If it's one of those ones with the big dip in the top, what do you call the big dip in the top?
Crater.
Crater, good. And then if it's totally like crushed down in there and it's a big caldera, yeah, that's the big one, right? That's the huge collapse depression at the top of the volcano, right? Excellent. So then you've got different kinds of eruptions. You've got quiet and explosive. Volcanoes erupt explosively or quietly, depending on what? What determines whether it's an explosive one? It has to do with the viscosity of the magma. Okay, so this is actually interesting. Then we get to what's interesting about rocks. This part's interesting. This part's interesting, Lily. So if you've got high viscosity magma, really thick magma, which means it has high silica,
Then it like
boom, because it builds up and it builds up and it builds up and it has to break that surface tension of that magma and then it goes kaboom.
but as it's low, it's quieter.
Right, if it's a low, thin magma that's got low silicate, it can ooze out, right? Those don't explode quite as quickly. What's the one we have here in the U.S. that was explosive back in the 80s? Mount St. Helens. Yep. Yeah, that was huge.
Washington State.
Yeah, Washington or Oregon. I always get those two places confused. I've never been. The places where it rains all the time and the trees are pretty.
Oregon.
Yeah, yeah, pretty much.
Seattle.
So yeah, Mount St. Helens. And do y'all remember last year I got the dust. Remember? Do you remember I brought it? There was a guy at the antique mall who had actual dust from Mount St. Helens eruption.
That's what he said.
That's what he said. He got it from his backyard when he lived there in a Ziploc bag, and it's labeled.
Parking lot, like scooping gravel.
Right? He probably did. You know what?
Like, you'll believe anything.
It was such a fine dust. You know what I worried? I'm like, what if this is like a dead relative? Like,
That's what I was thinking.
that's what I thought. You know, he could have sold me his dead aunt, and I would have known. Would not have known. I'd have been like,
My mom told you how she threw away my grandpa, right?
I heard that.
No.
Yeah. She threw away her. My dad put like this plastic bag of him into a jar, and my mom thought it was play stand, so she threw it away. She freaked out and like dug through the trash.
Did she find it?
Oh yeah.
Oh, thank God.
And now it's in the basement.
Oh, unless you make the truck came by already.
It was the day of, so she like ran out. Oh my God. It was so
Wow. That's a good one there.
It's like that's kind of.
Okay, who remembers the three main types of volcanoes?
I do.
Guys, hands are up.
It's a shield,
Uh-huh.
cinder cone, and composite.
Right, shield, cinder cone, and composite. So the shield ones are the big, low, flat ones. That's a low viscosity. It just oozes out over time. Cinder cones are the big, you know, conical
Rocky
ones.
A
Yeah.
rocky one.
They're the ones when you draw a picture of a volcano when you're 4 years old, that's what you draw, right? And then the composite ones are kind of in the middle. They have a lot of ash and lava. Yes.
I'll sacrifice myself to do 23.1.
Okay, well, we're almost there. All right, so other igneous features. We have batholiths. That's intrusive magma squeezed into a crack between layers of rock. Do we have a batholith in Georgia?
I don't know.
That's what the guy.
Batholith, remember?
Probably. Since
I'm
you
Yes,
said
we
it.
do.
Basilisk?
We have a big batholith. It's within driving distance.
Oh, that's it's a presidential thing, right?
No.
Hot Springs?
No.
Stone Mountain?
Stone Mountain, Shannon. Stone Mountain is a batholith, right?
Oh, I got Letty.
Excellent. And then we have a sill. And a sill is when the magma is parallel to the existing rock layers. All right, so you got rock layers that run like this, like the blinds, and one of them is filled with magma because there was a crack. That becomes a sill. And then a dike is the one that goes the opposite direction because it stops the flow. So that would be like if the rock layers are like the blinds, it's going to go that way, right?
What?
And
That
then-
sounds like an insulting term.
Now, wait. Think about it. Is this appropriate comment before you make it?
Fair
Okay. All right. Fair enough. All right. So,
I'm not gonna follow that.
and then a volcanic neck is the magma hardens inside the pipe, and the rest of the volcano erodes, and then you just have like a sort of like the chimney that's left, right? But it's a solid rock. That is neat. Yeah. I think that is
cool.
Volcanoes are cool. All right, Henry, do you want to tell us then about water?
Yeah, sure.
All right, go for it.
Stay hydrated first of all.
All right, why don't you read 23.1 for us?
Okay. What?
Do you mean it's a hydro flask?
Hydro glass.
It's not hydroponics.
Okay, read.
All right, go for it.
Okay. A, 71% of Earth's surface is covered in water. B, most of Earth's fresh water is in the form of groundwater found underground in cracks and in between particles of rock. It's you missed the D there.
Spit out.
And in between.
In between.
Yeah,
And okay, there's no somebody caught that one.
Oh yeah, I think
You
I
caught that one. Yep. Okay, keep going. All right, water cycle.
C, the water cycle, the movement of water among the oceans, the atmosphere, and land. 1, the water cycle is made up of several processes, including evaporation, transpiration, condensation, precipitation, and the eventual return of flowing water to the ocean.
Excellent.
And you forgot to indent here, but I'm not gonna
Yeah,
talk about that.
we're good.
A, evaporation. Liquid water returns to gas. B.
Okay.
I actually don't know what B is.
B, transpiration. That's water released from leaves of trees. Okay.
And then C is condensation, which is water vapor returns to liquid water.
Okay.
And D is precipitation, liquid or solid water falling from clouds to the earth.
Okay, excellent.
And then D is glacier, a large moving mass of ice and snow. But E is fresh water, which is the name of the section.
Right. Okay.
Small.
1.
Okay.
Small portion of Earth's fresh water is located in the atmosphere, streams, and lakes. Most if.
Is. Yep, you just caught it now. There you go. All right, that's 11. All right, most is located.
In groundwater and glaciers.
Okay.
A, atmosphere, tiny portion in water vapor and clouds. B, streams and rivers, even less fresh water in the atmosphere.
Yep, definitely less.
I, runoff, flows from Earth's surface. E,
Okay.
The dolphin.
All right.
what is that? An area that contributes water.
Tributaries. You get tributaries.
Okay.
Small streams that lead to rivers, and then watershed.
C, ponds and lakes. Forming
Usually drain into streams. So ponds and lakes form in depressions, the low areas, right? All right, and
2,
water beneath the surface.
A,
And come on.
saturated zone. Underground region where all the pores are filled with water.
Yep.
I, the water table. That's at top of saturated zone is the
Is there supposed to be the there?
No,
at top.
you don't need the in notes. You don't need articles. You can avoid them. Yeah, he's just trying to get more.
That's why We want those
I left
cookies.
those 3 blank because.
Okay, so the water table is up top of the saturated zone. All right. Permeable means able to pass water through it.
C, aquifer, rock layer saturated with water. D, impermeable, water cannot easily pass through.
Right.
Shock is the opposite of permeable.
Yep.
3, glaciers and icebergs. Icebergs are large chunks broken up.
Chunks broken off from glaciers. Yes. All right. I did. All right. So then weathering and mass movement. All right. So when we start talking about water and the forces of water, we talked a lot about weathering last year. All right. So let's whip through this stuff and wrap it up, because I'd like for you guys to be able to have a little time to. I have the beach ball game.
Yes! I don't even know what that is. I love the beach ball game.
So erosion acts through weathering, the force of gravity, and through the movement of streams, groundwater, glaciers, wind, and waves. So the main force in all of this weathering that involves water is what? Gravity, right? Okay. So weathering is the process by which rocks are chemically altered, or, that should say or, and I caught it, or physically broken down. There are 2 forms of weathering. There is mechanical weathering and chemical weathering. Anybody want to just define them quickly? Somebody tell me the difference. Cole.
Mechanical weathering is the process of the physical process of breaking down rock in small pieces, and chemical is done through chemical reactions.
Can you give me an example of either? Hang on, Cole.
Water running down a hill would be mechanical.
Okay, because it will erode the rocks on the way down. How about chemical?
Maybe sunlight.
Acid rain can cause chemical. Can you give me an example of chemical erosion that you would see? How would it occur? What would it cause? Do you remember the big one that we talked about it a lot? When the water with the acid seeps into the ground, what does it erode underneath? What does it weather underneath? Limestone. And what does that cause?
Sinkholes.
Caverns and caves, and then eventually sinkholes, right? That's how we get it. Excellent. Boom. All right. Rates of weathering. The rate at which weathering, no?
Is that how you spell disintegrate? D-S. D-I-S.
You really want cookies, don't you?
Where are you?
No, I'm just pointing out her flaw.
Where is it?
That's not gonna be
Oh, disintegrate is not, it's not giving me any other spelling for it.
That's how you
Okay.
Yeah, I'm pretty sure it is.
Okay.
I'm bad.
Rates of weathering, and I can be bad at it too. Actually, what I'm bad at, I'm not bad at spelling, I'm bad at catching it when I misspell. That's you know, the beauty of ADHD, I don't see it. Mechanical weathering is the process physically breaking down, like he said, and chemical weathering is when it's broken down by chemical reactions. So the rates of weathering, the rate at which mechanical and chemical weathering takes place depends on 3 main factors. What are they? 3 main factors.
Warm water.
What?
Still adding.
C1.
Availability of water.
Availability of water.
Type of rock.
Type of rock. What's the other one?
Temperature.
Temperature. All right. How does a cold temperature and the availability of water affect weathering of rock? What can occur? What can occur? Do you remember?
Warm water.
Henry, stop. What happens with water if it gets into a crack of a rock and then it gets really, really cold?
It freezes and then it expands.
Correct. And it breaks. It can break a rock. It can split it right in half. Water can split a rock in half. All right. So then looking at mass movement. So that's the downward movement of rock or soil due to gravity. And there are all kinds of mass movements. They typically go downslope because, again, gravity is the main force. So we have landslides. That's rapid downslope movement of large amounts of material. Mud flows are rapid mass movements of soil, sediment, and water. Creep is this slow, gradual downslope movement of soil that you usually cannot observe with your eyes. It's something you see over time. Remember, we had pictures of like fence posts that had been shifted over time, things like that. And then slumping is when you get weak layers of rock or soil that move downslope as a unit, like a big chunk of it just kind of goes thump.
Like this time.
Yep. And if you remember, we looked up some videos and pictures last year of landslides and mud flows that were just phenomenal. Remember, some of them were crazy, like entire towns wiped out in 10 minutes and stuff. It was unbelievable.
I'll sacrifice myself again for 23.3.
Well, I'm gonna read through them because I'm watching our clock and I just want to read through them. So 23.3. So we have deposition. That's the process in which sediment is laid down. So you've got water with sediment in it, and as it goes, the sediment stays behind and the water keeps flowing, right? So running water erodes land. You've got saltation, which is the process of particles bouncing along the bottom of a bed. Do you remember I told you there was that same word, that saltation, that same root at the beginning of that word? There's a term in biology called saltatory movement. Do you remember what that means? No. It means movement that goes like this.
Oh, yeah.
And
It's called bouncing.
animals,
Sorry.
some animals, locomotion is what we call saltatory movement. Can you give me an example of an animal? That kangaroo. There's one. No,
Bunny.
a caterpillar. Bunny,
I said
caterpillar.
that, you stole that.
No, I didn't even
Yeah, you
In
did.
your body,
There.
your nerves, like your motor neurons. So here, this will help you remember.
Dolphins all the time.
Your motor neurons in your body that help control your muscle movement, for example. Y'all know about electricity moving down a wire this way?
Yeah.
We're gonna talk about that this year too. It's faster than going like this. Jumping is faster. So
Yeah.
Do you remember-
It has gravity
do you
that
remember
way.
last year when we talked about you have a neuron like this and you've got all these little dudes? Do you remember axons, dendrites, and all that business? Okay.
Totally.
Do you remember? It was 2 years ago we talked about this.
Oh,
All right. On them, you have these little things like this, okay? And it's called a myelin sheath, okay?
Yeah, I remember that.
All right. Saltatory movement would be that your signal comes in here. When it gets to here, it goes boom, 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 which is way faster than going straight,
Yeah.
okay?
Cool.
There is a very well-known, you probably know somebody with it, disorder, where these stop working. They fall apart and you lose some. So instead of it bouncing, it has to go, right? Slower, slower, slower. You know what that is?
It's it's not. It's the one where you get less and less.
ALS?
Yeah.
Multiple sclerosis?
Yeah.
That's what happens. Yeah, it's the loss of the myelin sheath around your neurons.
You get less and
Multiple
less strong,
sclerosis.
you get- Yeah.
So you can't control your muscle movement as well because the signals don't move as quickly.
No.
All right, so that's saltation. A stream's ability to erode depends mainly upon its speed. All right, features formed by water erosion. So now we're at 23.3, C1. So water erosion forms V-shaped valleys, waterfalls. Do you remember meanders?
Yeah.
And oxbow lakes. Do you remember oxbow lakes?
Sure.
Oxbow lakes is when you have the meander.
What is that?
You got a little meander. It's a stream, right? It's going like this.
Is this bird's eye view?
Yeah, bird's eye view.
that's how birds
Okay.
do things.
And over time, this,
Everything's your eyes.
over time, this and this erode, right? And this erodes so much that gets cut off. And then you have an oxbow lake. Do you remember that? Like this corner here will get thicker and thicker because it whips around, and this corner gets thicker and thicker.
Yeah.
And then sooner or later, you end up with this, right? These little separate things, oxbow lakes,
That's an oxbow lake.
oxbow lake.
But how does it erode so much to cut it off? Because isn't eroding it keeping water flow in it because it's getting rid of
So-
sediment from piling up?
Yeah. So look, when you've got, let's say it's going this way, okay? That's your meander, all right?
Okay.
So right here and here, they're very close together. So as it whips around the corner, do you remember when it whips around the corner this way, this side is slower and this side is faster,
Oh, okay.
right?
Okay.
So as it's faster, it erodes more of this. Same thing's occurring here. This side is slower, this side is faster. So it's eroding here. Sooner or later, it erodes and they come together. Once they come together, they kind of start to reform the flow going this way, and then this
Okay,
guy gets
yeah.
cut off, right? Okay. Okay. All right. So, floodplain. What's a floodplain? What's a
Oh,
floodplain?
it's supposed to flood.
Plain
So
of
it's
flooding.
after.
After flood. Like
Yeah, it's supposed to say flat. Y'all caught that
There's
one.
on-
It's a flat area. Yeah, there's one on McGinnis Ferry that you can see right there next to the bridge.
Yeah.
It's a flat area where when there's a flood, it becomes entirely covered in water.
Yeah.
So
Is
features
there a
formed.
swamp on the way to the polo fields.
Yeah, there's one in there too. Features formed by water deposition. All right, so features deposited by flowing water include alluvial fans and deltas. Where's our most famous, well-known delta in the U.S.?
Hartsfield Jackson.
The U.S.
Nile.
Not that delta. How about, yes, remember?
Rio Grande River.
That's a good one. Our best known delta is at the bottom of the Mississippi. You remember? Mississippi River comes down and heads out into the Gulf of Mexico. And a delta is always shaped like you got the river that comes down here, and here's your main body of water, right? And when it comes down, it spreads out like this. And this is your delta. What is the Greek letter for, what's the Greek letter delta look like?
It's a triangle.
It's triangle. What does
I
this
did that
mean
wrong.
in science? If you write
Illuminati. Oh, sorry.
if you write it on its own, what does it mean?
Delta. Right.
What, it's a synonym for,
Let's do.
it's a synonym for
Water. Change.
Yep. change. What's the delta?
You tried.
Just means change. Yeah, it could mean that. It could mean,
Triangle U.
say we did 2 experiments where we took temperature. And in your first one, you had 101 degrees Celsius. And in your second one, you had 120 degrees Celsius. And I said to you, what's your delta? What would your answer be?
Oh, it's
Triangle.
19.
19 degrees Celsius. That would be your delta. What's the change? Okay? Change difference.
What's the
And then, yes, and what's Delta's, Delta Airlines, what's their logo look
It's
like?
a triangle, but I don't understand what that has to do with flying. Is it like changing location? Is that
I don't know. They just picked it. They could have picked Sigma. Anyway, all right. Yes.
I didn't know what Delta Airports looked like their logo.
Yeah.
Oh,
Mhm.
yeah?
Like a
Mm-hmm.
It's
a triangle.
Hartsfield Jackson's
Right.
Delta logo looks like a triangle.
Hartsfield Jackson's mostly Delta run and it's
Yeah.
big rectangle.
Well, not the airport, the airline logo.
Yeah.
Okay,
I
so
thought you said Delta
what's the
Airport.
alluvial fan look like? Do you remember what the alluvial fan looks like? So that was really cool. It's pretty. That's when you've got like a stream that comes out like this, and then at the bottom, kind of where, almost like where a delta would be, you've got layers of the sediment that over time have spread, and they're usually different, lighter things, heavier things, and it gets really, it's really pretty. They look really neat. That's your alluvial fan. Yeah. Mm-hmm. A lot of times they're where it's dried up, like it's a dried bed. It's not active all year. All right, and then ground erosion. So here we go again with our ground erosion. The process of chemical weathering causes much groundwater erosion, including the formation of what and what?
Caves and
Caves and sinkholes. That's what we talked about. All right, which hangs and which grows from the bottom? Stalagmite, stalactite.
Stalagmite grows from the top. And the bottom.
Stalagmites might touch the top one day. Stalactites hang on tight.
There you go. That's how you remember it. That's right. Stalactites hold on tight. Stalagmites might touch the bottom one day. Okay, might touch the top one day. All right, glaciers and wind, 23.4. And look, we're getting done. We're almost done. 23.4.
Already.
Glaciers and wind. How glaciers form that's a bet. I caught it, not you. And move. Glaciers form in places where more snow falls than melts or sublimates. What's sublimate? Do you remember?
No.
Is that actually?
Okay, well, melt is a clue. Melt is a change of physical state.
It's a change of matter. Is it not?
It's a change of physical state of
Isn't that
matter.
similar to condensation?
All right, when okay, if I brought dry ice in here, what state of matter is it?
It's a solid,
It's a solid, correct?
but solid to gas.
Correct.
Evaporating.
Correct. So sublimation is when you go directly from solid to gas without turning into a liquid in between. Goes directly from one to the other. Do you remember what I told you was proof of idiots on the internet with the snowball and the lighter?
Yeah, it turns plastic.
Do we remember this?
Plastic
Yeah.
I told you every time it
Snow,
snows,
Plastic.
Yep. every time it snows,
Conspiracy theory, we're all gonna die.
there will be some Nimrod on the internet who will make a snowball and go, look, it's activated, it's plastic, it's not real, it's chemtrails. And they'll take a lighter and they'll hold it next to the snowball, and lo and behold, it doesn't turn to water. It goes from ice to poof, it's gone. Well, it's not gone. It turned to gas because it's sublimated, because they went super hot because they get the fire on it. And then, shocker, it gets soot on it because that's coming from the butane in the lighter, but they'll say, oh, it's plastic. The government's going to cover us all in plastic snow.
America.
So, America. It is proof that there are
We're covering up.
idiots among they live among us, y'all, and they vote and reproduce.
Flat earthers.
Stop.
They float.
They vote and they reproduce. I'm telling you, it's terrifying. Okay.
No, because they're dumb. They won't.
No,
No, they vote.
How do you think?
Trust me. Yeah.
Okay,
Okay, how glaciers move and form. All right, a continental glacier covers large areas of land. Where's the most obvious continental glacier right now? Antarctica. There you go. It covers the whole thing. You got valley glaciers, and they form down in the valleys, right? Everything rolls down. You got a valley glacier. All right, glacial erosion and deposition. Plucking.
Really
Do you remember
complicated.
plucking?
Yeah.
Plucking was as the
It grabs.
yeah, so as the glacier moves along and it rolls along, gravity's pulling it, it grabs stuff, right? Plucking. It grabs things along the way, grabs big rocks. And you got features by glacial erosion. So you've got lots of distinctive features in the landscape, including cirques, horns, U-shaped valleys, and glacial lakes. So that's a bunch of stuff, all right? You can look all those up if you want to see what they look like, but you really don't need to know them for the purpose of this test. Okay, when a glacier melts, it deposits its load of sediment, creating a variety of landforms. So till is the one that we saw a lot of, right? That's the till is all the stuff it's brought with it, and when it melts, it just leaves like this pile, for lack of a better word, of it all. And then moraines were the little mounds, right? And it's at the downhill end of the glacier, whereas the till can be along the sides of it, tends to be. Wind erosion and deposition. Wind erodes the land by two processes. One of them was abrasion, right? It's where it scrubs it. And the other one was where it takes it away. What do we call it when it takes the soil away and it gets lower?
It's
Come on. It's in your notes. Are you looking at it? Right there. Dude, where are you? Deflation. Deflation. It blows it away and it deflates, right? So features deposited by wind include sand dunes, less deposits. And we did dunes. We did the lab with the dunes. That was when there were very few people here that day. You were here. Katie and Michael were here.
I was here.
Yeah, you were here. We went outside and we did the box with the sand in it and the hair dryer, and we formed dunes based on different positions of the wind.
You did it without me?
That was fun. I don't know where you were.
It was kind of cool.
You were
It was
sick.
cool.
I think you were sick.
Yeah.
It was like the week that everyone was sick.
Yeah, there were only like 5 or 6 people here that week. Really light week. So then you have less, which is deposits of the windblown dust. All right, and then we get into this restless oceans. Let's breeze through this quickly. Yes, a question?
I think this looks a little bit off in that Restless Ocean A5 2A.
A5-2A.
Hydraulic action.
Yeah.
When waves, my bad.
You got it? Okay.
Oh my bad.
So, all right, exploring the ocean. That's fine. That's okay. So, the proportion of salts dissolved in water, what do we call that? How salty the ocean is it salinity, right? All right. And with depth, you get changes with light and temperature. What does the temperature do with depth?
Cool.
It decreases. And what does the light do with depth?
Warms it up.
It decreases. The lower it gets,
That makes it higher.
the lower it gets, the darker and colder it gets, right? All right. And then you have the continental shelf, which is this slow sloping thing that comes off the edges of all the continents. You got ocean currents. All right, so a surface current is a large stream of water that moves continuously in about the same path, and winds blow across the surface of the ocean, cause continuous flow. All right, deep currents are caused by differences in what?
Density.
Density. All right, so what causes density to be different? Do we remember?
No.
There were 2 main things that cause the water to have different density.
Stuff in it.
Yeah, what stuff? What's in it?
Salt.
Salt, and what's the other thing?
Sediments.
No,
Sand.
temperature. If you have a pocket of cold water and a pocket of hot water and they come together, what's going to happen?
Gas.
No. A pocket of cold water and a pocket of warm water come together, what's going to happen? Think about it.
Change
Which one is more dense?
the cold.
The cold. So where's the cold going to go?
It's gonna go down.
It's going to go down and it's going to create a current.
Oh.
All right? Now, what if you have super salty and fresh water and they come together? What's going to happen?
Oh, it's the super salty goes below.
Going to go below it and it's going to cause a current. All the currents in the ocean are caused exactly that way, right?
Epic.
Epic. Epic. All right, so then upwelling, that's when the water comes from the bottom up. And let's see, in upwelling, wind blows warm surface water aside and allows cold water to form, from the deep to rise and take the place of warmer water. So we have wave erosion and deposition, two physical processes, hydraulic action and abrasion, are responsible for much of the wave erosion. So hydraulic action was when the waves pound the rocks, right? And longshore drift, if you've ever been at the beach and your mom and dad are here on the sand and you get in the water and you're like, hey, and 5 minutes later, you're like, where are my parents? They're way down there because you've been
Yell at
moving.
you because the currents take you away. You're
Longshore drift, down you go, yep. And everything flows that way, right? All the sediment flows that way, not just the swimmers, right? And the fish, it all goes that way. And then you have deposition by current and waves. All right, let's real quickly look at this last bit on Earth's history timeline, and then you should have a few minutes to hopefully go outside and do beach ball game. Yes, you have questions?
Yeah, you didn't put the 23.6 in her.
Yeah.
Oh yeah, you noted that. Yeah.
Dylan.
Mhm. Yeah.
Dylan.
Somebody caught that.
I think I did.
I probably did. Oh yeah, what did I do? 4.
Where are you going, Henry?
Henry,
Whack me.
Henry, come back into lessons over, please.
I need to kill the
we need to finish this so we can go outside and play.
We got Lily. I got 1, 2, 3, 4, 4, 5,
I need my daily.
and then 6.
Whack.
I got them right.
By the way, my record's 37.
All right, last couple of minutes. Are we with it?
I'm here.
Are you paying attention?
I'm not
All right.
whacking anything.
What is it called?
It kind of starts repeating. It goes,
Oh, wait a minute. Are you looking at chapter 22 versus chapter 23? There you go. All right. So, what do you call it when you compare when you determine a rock's age by comparing it to other rocks of the same layer? What is it? You know it.
Hidden gems.
What is it called?
I know it. Hold on.
She knows it.
It's relative age, right?
Yes, relative age. Good.
I didn't look at that.
And at the beginning, I said it. The law of superposition means that what kind of rocks are at the bottom? Oldest rocks are at the bottom. Shh, guys. All right. And geologists use the law of superposition for relative age, right? All right. What are the fossils that you use that are easily identified? They cover a large area and they have a definite time period in which they existed. What do you call those? Index fossils. Thank you. So index fossils are things that only live for a relatively small period of time. They're everywhere, cover a large area, and they're easily identified.
So
It's
like
not
seashells?
some types. Could be.
I thought
Other organisms.
Seychelles was an island in the middle of an ocean.
Cool.
All right.
Seychelles, my bad, Seychelles.
Seychelles. All right.
Say.
Those are index.
Say.
All right. What do you use to determine the absolute age? What's absolute age and how do you find it?
Radioactive dating.
Radioactive dating. And what is absolute age?
It's the
Time
age
passes
versus
the rock is formed.
Yes.
Age that actually.
Yes. And what do they use when they do radioactive dating? What do you use? How do you do that?
Whoa.
What specifically do you take advantage of? Do you remember? They pick the half-life of certain elements in the rock, right? Y'all are, I'm losing you. All right. What's the longest period of time? What's the longest period of time? Eon. All right. What's the shortest period of time?
Epoch. Seconds.
Milliseconds.
Milliseconds.
In geologic time,
Oh.
you had it, an epoch, all right? What is the second longest period of time?
Billion of a second.
No, second longest period of geologic time.
Period.
I don't know.
You know it. You know it. You are the paleontologist.
I just like dinosaurs. I don't know anything
Eon,
else.
era,
That one. I know that one.
period,
Epic.
epoch. Eon, era, period, epoch. All right, Ethan.
Huh?
What is mass extinction?
It's where a lot of a big area of living things
Die.
just die very, very quickly.
All at the same time.
Just-
Right. All right, and then I gave you a printout, a little picture of the geologic time scale.
We did a lap
We've
back.
got-
It was boring.
Cenozoic, Mesozoic, Paleozoic, Precambrian. That's the one where we drew it out on the long piece of paper. So I gave you an
That
idea.
one sucked.
All right.
It's just that they did nothing.
Yeah, we're trying
So,
Y'all know the rules.
y'all, hold on. I'm going to stop mirroring for a second. Yeah, I'll figure it out in a second. They should just come in.
Okay.
Let me see if I can do this without watching this.
No, he's up.
Stop share. All right, hang on. Wait a minute. Before I send you outside, you're going to have 5-10 minutes. But before I send you out, wait a minute. Guys, you've got to get together. You are high schoolers, even if you're not high schoolers in this grade. Huh?
You're still children.
Nah. All
Very few of us are.
right, listen.
Y'all
Y'all are going to miss it. If I were you, I'd have a piece of paper and a pencil kind of nearby. And I would just listen for a minute. I would just, maybe just listen. I would just maybe listen for a minute. I would just maybe listen and say that, when it comes time to take your test, you're going to need to understand things like uniformitarianism and maybe types of rocks and maybe the definition of mineral. Basic idea of the rock cycle. Gonna need to understand why earthquakes occur and where they typically occur. And about, maybe plates spreading on the ocean floor. And what causes volcanoes to erupt quietly or explosively. And what kinds of volcanoes exist.
Ooh.
And the water cycle would be good to know.
What's a water cycle?
It's in your notes.
Michael,
I
don't
was
make
about
this
to actually
wrong.
say
And
She said.
let's see, where you're gonna find a lot of fresh water on Earth, and the types of rock weathering, the idea of deposition and what it is, what an aquifer is, and the difference between the two types of age dating we just talked about for rocks. Those would be really good
We're
things
still
to
only gonna have an hour to do
study.
the test.
Yeah. But I see what I just did there is I took your 4 pages of notes. So what you might want to do is take that information and go back through your notes and kind of circle, 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 circle. All right, so here's what I'm going to do. You guys have 9 minutes, and I'm going to, hold on.
We heard 9 minutes. We're like,
So you got 9 minutes. I'm gonna take the beach ball, and I'm going to toss it out back for you, but you want to get out there first, okay?